Half a day, students. Today's lesson is really short. It's about ratios. So ratio is basically just a fraction. So when we say a proportion is an equation that states that two ratios are equal. Basically, we have a fraction is equal to another fraction. So this would be written something like A over B is equal to C over D. And when you're reading this as a proportion, you say A is to B as C is to D. Solving a proportion would be to find the value of a variable. So if a variable is using this, for example, if we have like 9 over 5 is equal to 4 over x. Basically, if I was to find x, that would be solving the proportion. Cross product property. This states that the products of the extremes equals the product of the means. I don't really expect you to memorize what means and extremes are, but basically it just means if we have A over B is equal to C over D, this just means that if I was to cross multiply, AD is equal to BC. Means and extremes, just A and D are the extremes, B and C are the means. It doesn't matter which one's which, but just know that the ones that are across from each other, if you multiply them, they'll equal. Now we're going to go into solving proportions, and we're going to be using here the cross product property. There's another property called the reciprocal property, which basically states that 3 over y equals 5 over 8 is the same as y over 3 equals 8 over 5. Like if you flip it, then it still works. But I think it's the cross product property is the most useful, so we'll just use that to solve all of these. So firstly, we'll do 3 times 8. So 3 times 8 is equal to 5 times y, or 5y. From there, 3 times 8 I know is 24 is equal to 5y. To get rid of that 5, I want to isolate y, right? To solve for it, I'm going to divide by 5. So y is equal to 24 over 5. And if I was to just plug this in to check my work, you can always check your answer. So I'll just put it over here. Okay, if I wanted to check, I would put 3 divided by 24 over 5 is equal to 5 over 8. And we know that 3 divided by 24 over 5, when you're dividing by a fraction, it means you're multiplying by its reciprocal. So this would just be 3 times 5 over 24. 3 times 5 is 15 over 24 is equal to 5 over 8. If I was to divide both of these by 3, I would end up with 5 over 8 because 15 and 24 have a common multiple, 3. So this is correct. So y is equal to 24 over 5. Looking at something like this, notice I have x's on both sides. I'm still going to do the same thing, I'll cross multiply. So I have x times x, that is x squared is equal to 12 times 3, which is 36. I'm going to take the square root, right? When I'm solving, I'm going to take the plus or minus. So x is going to be equal to plus or minus square root of 36. I know the square root of 36 is 6, so x is equal to plus or minus 6, or positive 6 or negative 6. I know this is true. We can also check it by plugging them both in. So we'll try 6 first. 6 over 3 is equal to 12 over 6. This is true because 2 equals 2, right? If I was to check negative 6 over 3 equals 12 over negative 6, I would end up with negative 2 is equal to negative 2, which is also true. So these are my two solutions. Sometimes you might have something a bit more complicated. It won't be super often, but this is a good skill to have for future math courses. You'll do the same thing. 2 times y squared minus 9 is equal to y plus 3 times y minus 3. 2 times y squared minus 9, that's equal to 2y squared minus 18. Here, when you multiply binomials, remember that we have to FOIL. So we have y times y is y squared. Outside minus 3y plus 3y minus 9. Okay, this 3y and negative 3y will cancel each other out, so we have 2y squared minus 18 is equal to y squared minus 9. So we can actually just try moving these all to one side, see if we can solve it from there. I'll subtract y squared. So minus y squared minus y squared, I'm left with y squared plus 9 plus 9. Okay. So y squared negative 18 plus 9 is negative 9 equals 0. Here I'm able to solve by factoring. This is all chapter 10 stuff, right? It's something that we said was going to come in a lot. So y squared minus 9 is equal to, this is a difference of squares, y plus 3 times y minus 3 is equal to 0. I know that this gives me two values of y, which are negative 3 and positive 3. Again, you could check by plugging it in. Lastly, we'll look at writing and using a proportion. So we're going to look at its application in real life problems. This is one of the things that's the most valuable for real life application because we deal with a lot of ratios in everyday life. For example, if you're cooking, right, and you have a recipe and it says it's good for 4 people, but in your family, maybe you're making it for 12 people, right? So you'll be able to find a ratio to see what would be a good amount for you to make to accommodate for more or less people or other things like that. So for this example, we're looking at making a scale model of something. In this case, a parade float. So if you want to make a scale model of a parade float, and when I say something is to scale, it means it has the same proportions, right? Like if I was to blow it up, then it would be exactly how it's supposed to be. So the float is 5.5 feet high and 10 feet long. Your model will be 14 inches long. How tall should it be? So your ratios need to be equal, right? We need to set up a proportion. So first of all, I'm going to do is I'm going to say, okay, it's going to be the height over the length. So the height and the length are going to have the same relationship to each other. Okay, so the height is going to over the length. And for my, this is what I'm going to use for the basic one, and I'll set one up for the actual parade float. So the actual parade float is 5.5 feet for my height, right? And it has 10 feet for my length. And when I'm building my model, I know I want to make it 14 inches long, so that's my length, right? That'll be on the bottom. I don't know how high I should make it, so I'm going to use a variable here. So if I know I want to make a certain length, I need to find out now what the height needs to be. Put a variable there, then I can just solve normally. So 5.5 times 14. We can use a calculator, or you can just do 5 times 14 is 70 plus half of 14. So this will be 77. It doesn't matter which side which is on, okay? So then we have 10x. Now we'll just divide by 10. So x is equal to 7.7 inches. So it should be 7.7 inches tall in order to make it to scale. So what you would do to apply ratios, you would set one up and then be sure to keep the appropriate measures on the correct side of the division symbol, the fraction line.